Hello everyone and welcome back to My Wave. I'm Shashi and in today's video we are going to talk about attenuators, what they are, why they are used, how they work, and how to choose the right attenuator for your application. Even though attenuators are relatively simple devices, they are found in almost every RF, microwave, and millimeter wave test setup. So let's get started. What is an attenuator? An attenuator is a device that reduces the power level of an RF signal by a known amount. Think of it as a volume control for RF energy. An amplifier makes a signal stronger. An attenuator does the opposite of it, makes the signal weaker in a controlled and predictable way. So why would we want a weaker signal? There are several reasons. Sometimes we need to protect a sensitive receiver or test instrument from excessive power. Sometimes we want to simulate signal loss that would occur in a real communication link, and often we simply need to adjust signal levels to obtain accurate measurements during testing. Let's look at common lab application. Suppose you are testing a low noise amplifier. The amplifier output may be too powerful for your spectrum analyzer or measurement receiver. Adding an attenuator between the amplifier and the test equipment protects the instrument and allows accurate measurements. How does an attenuator work? Inside the attenuator, part of the RF energy is absorbed and converted into heat, while the remaining energy passes through to the output. The amount of reduction is specified in decibels or dB. Now let's look at the different attenuator options available from My Wave. We will start with fixed attenuators. As the name suggests, fixed attenuators provide a fixed attenuation value that cannot be adjusted. If your application always requires the same attenuation, this is typically the simplest and most economical solution. 521 series is designed for low power applications and is often the lowest cost option. 524 series is designed for high power handling and is commonly used at transmitter outputs, power amplifier outputs, and other higher power applications. If your signal level never changes, a fixed attenuator is usually the best choice. Now let's move to the adjustable attenuators. The 520 series dial type attenuator allows you to manually change the attenuation using the rotary dial. This is useful when you're working in a lab environment and need to quickly adjust the signal levels during testing. Once the desired attenuation setting is selected, a locking knob can be used to secure the position. This helps prevent accidental movement of the dial and ensures that the attenuation setting remains unchanged during setting. This is 520 dial type attenuator. Before making any adjustments, ensure that this reading window is facing towards you for clear visibility of the dial position. This is dial knob, this is dial scale, this is reading window, and that is stopper knob. This is currently in open position. When you have set the attenuation level, you can move this or slide this stopper knob into lock position so that the attenuation does not move accidentally. I will keep it back in open position. So right now the reading window shows 0 and this is the calibration sheet at 0. So for increasing the attenuation, you rotate the dial knob in clockwise direction. For decreasing the attenuation, you rotate the dial knob into counterclockwise position. So at this moment, the attenuator is set as its minimum attenuation value, which is 0. If you want to increase the attenuation, you slowly start moving it in clockwise direction. So let's say we want to set it at 118 position, where the attenuation value will be 1 dB. So let's start moving. Let's start rotating the knob in clockwise direction. The reading window now shows 1, which corresponds to value written here as 1. Now you have to set this dial scale at 18. So you slowly move till 10, align it here. Now each division is 2 points, so that is 12, 14, 16 and 18. So the attenuator setting is at 118 and the attenuation value at this setting is 1. Since this is variable attenuator, MyWave provides calibration data at center frequency. The calibration sheet indicates attenuation values corresponds to each setting. Calibration data at the other frequency points can also be provided if requested at the time of order. If you need finer adjustment and higher precision, the 523 series micrometer attenuator may be the best choice. Instead of a dial, it uses a precision micrometer mechanism that allows very smooth attenuation adjustment. This is our 523 series micrometer type attenuator. So we have two scales for this attenuator. One is vertical scale and another one is horizontal scale. Vertical scale is stationary while horizontal scale is moving. In here, the vertical scale, here is the indicator. So when you are changing the attenuation, make sure that this indicator, the vertical scale, faces towards you. For this attenuator, to increase the attenuation, the dial knob will move counterclockwise, and to decrease the attenuation, you will have to rotate this micrometer to clockwise direction. So on the vertical scale, each division is 50 points. So let's read it out. This is 0, this is 50, here it is 100, then 150, 200, 250, 300. So this, if I rotate the horizontal scale and align it with 0 reading, now we are at setting 350. Let's do it again. On the vertical scale, 0, 50, 100, 150, 200, 250, 300 and 350. So right now the vertical scale is at 350. The horizontal scale, each division is 1 point. So if I start moving this micrometer by one division on the horizontal scale and align it with this indicator on the vertical scale, so the reading would be 349. I move one more division, the reading would be 348, 347, 346 and 345. It's going to be 340 here, 335, 330, 325, 320 and 315, like that. So as you are decreasing the attenuation, the dial knob is moving clockwise direction, as you noticed here. So this is how you can operate our 523 series micrometer type attenuator. So on the calibration sheet for 523 series, the dial setting, or you can say micrometer setting, when it says 415, you have seen how we adjust it at 339, 345. So that particular dial setting will have a particular attenuation value, which we will give you the calibration sheet for. Just like the dial attenuator, calibration data is provided so engineers know the actual attenuation corresponding to each micrometer setting.